All right, we'll just I guess dive right into it. This is the notebook. I've posted this draft version up on my GitHub. So git fetch upstream, git merge upstream master, or git pull upstream master. That should do it. Make a copy, and you can follow along, add your notes as you go. All right. It's all up there. We're all good. Can we get started? Okay. Then let's take a look here. All right. So we'll talk about dictionaries today. Sorry, I don't know why it feels so loud or unstable here. Okay. So the data structures that we've talked about in Python so far, we have lists and tuples, and I think that was about it so far, lists and tuples. And then we talked about the different data types, like the strings and the booleans and things like that. And today we're going to talk about dictionaries. Dictionaries are they are an unordered mapping of keys to values. Okay, so in a dictionary, you have a set of keys, and then you have a set of values. And they are very useful for looking up a particular value if you know the key. Okay, so these are, something's a dictionary if it's got curly braces. Okay, you've got curly braces to kind of define the dictionary, and you pair up each key with a value using a colon. And so here I've created the keys Adam, Bob, and Carl, and they take on the values 25, 19, and 30. So maybe these are names and ages, okay? So that creates the dictionary, and when you just ask what does this dictionary looks like, it looks exactly like what we created there, okay? You can also create dictionaries in other ways. You can take two lists and do what Python calls zipping them together. Okay, so technically, if you zip two lists together, it creates what's called a zip object, which in most of my encounters have always been turned into a dictionary. But I suppose there's something kind of underlying it that makes it a little different here. So here I've got two lists of equal length. One list has the names Adam, Bob, and Carl. The other list has the values 25, 19, and 30. And I use zip to zip them together, and it creates a dictionary. Okay. If you just use the zip function, it creates a zip object. But you can see that the result of creating the dictionary using the zip is equal to just creating the dictionary kind of our old-fashioned way of kind of typing out each key and value together. But the zip is useful because sometimes you'll have a function that outputs a list, another function that outputs a different list, and then you can just zip them together. So you can take two lists and zip them together like that. All right. Once you have a dictionary, you can access the value using the square bracket, okay, and you provide it the key, okay? So here I say, what is the value associated with the key Bob in people, okay? There's also a specific function for doing this, and this is called get. It's a method for dictionaries, okay? And so you can do people.get and get the value associated with the key Bob. Here you can do, and if we look at if we use a key that does not exist, right? So our keys are Adam, Bob, and Carl. If you say, try to get, or if you say try to get this value, okay? What is the value at Joe? It throws a key error. It says basically this key does not exist, right? Key error. That's all it says, okay? If you run people.get, so this is kind of the difference between the square bracket and the get method, okay? Because effectively they do the same thing, okay? Except when you give a key that doesn't exist, okay? So the get will return a none, okay? If you give it a key that does not exist in the dictionary, get will return none, whereas using the square bracket, which I think most people use most of the time, that will throw an error, okay? Just, this is a little bit easier, but when you write functions, probably get might be the preferred, or I don't know, because this might be like an exception that you can catch, right? But as you're just kind of interacting with Python, I think most people just use a square bracket just because it's easier, and it's very similar to what we're accustomed to in terms of like subsetting lists and slicing lists and things like that. Okay. Keys itself can be numeric, okay? In our examples here, the keys have been names, like Adam, Bob, and Carl. They've been strings, but keys can be numeric as well. So, here I am going to create a key 2 and a key 1, okay? And the values themselves can be lists or other things as well, okay? So this is going to associate the list with the values 20, 4, and 5 to the key 2, and this will associate the list, the value 10, okay, integer 10, with the key 1. All right. When you do this, you can say what is the value in dictionary with the key 2, and it tells you that it's 24 and 5, that list. And if you say what's the value at key 1, it's the value 10, okay? An important thing to know in Python is that dictionaries are unordered, and thus there is no index in like a list. So a list has an index starting at index 0, and if you want like the third item in the list, you can say I want the value at index 2, right? Because it's 0 indexed. Okay. Think of a dictionary as a bag. Okay. There's no order to the objects inside a bag. Okay. So it does not make sense to talk about reach into the bag and grab me the third item. Okay. Because there's no order. So a dictionary has no order, and so you cannot use numeric indexes. You cannot say give me the 0 index object. You cannot say give me the object at index 1. Okay. If I do this, what will it throw? So I'm doing people 0. Okay. What will I get? I'm going to get a key error, right? Because this key does not exist. Okay. There's no sense in trying to index a thing. So if you try to say give me something at 0, it's going to throw a key error. This key does not exist. Okay. These work here. It looks like I'm saying what's the value at index 1, but it's not. This key actually exists in the dictionary. This key actually exists in the dictionary. So those things. So that works, but there's no ordering to a dictionary, which feels a little bit strange. We're not used to having these unordered sets. Okay. All right. You can use these key mappings to create new entries in the dictionary as well. So you can, and you can also use it to kind of just modify the value associated with the key. So here is my current dictionary. The current dictionary says key Adam has 25, Bob and Carl, and they have their values. Here I'm going to say people and then provide the key Derek, which does not currently exist in the dictionary, and I'm going to assign it the value 33. And then I'm going to assign 26 to key Adam, which does exist in the dictionary. Okay, so because these, so Derek is going to create a new entry, and then with the thing that currently exists, it's going to modify that existing key value pair. Okay, And it doesn't look like much happened, but then again, when we print out what is people, we can see indeed Adam has changed values to 26, and Derek is a new entry here with the value 33, okay? And it looks like we're just tacking things on, and it looks like there's an order, but there's not, okay? There's not an order. Okay, if you want to remove a key, you can use delete, del. All right, so here's this, and indeed we now have gotten rid of Carl. We have Adam, Bob, and Derek. Okay. If you do people.pop, okay, people.pop, maybe the comment gives us a hint. But what do you think people.pop will do if I just run it like that? Okay. So what does pop normally do if you do a list? Pop with no argument provided will pop the last object, right? Okay. Dictionary is there a last object in dictionary? It doesn't exist. So if you do people.pop, it gives you an error because it says pop without any arguments provided. I'm going to pop the last thing, but a dictionary doesn't have a last object, okay? There's no ordering in a dictionary, so we get some kind of error, right? So if you want to pop something, you have to provide it a key that exists. Okay, so here I pop Adam, and it returns the value 26, okay? And so what will my dictionary have now if I ask for the dictionary? It's going to just have Bob and Derek left over, right? So because we've already deleted Carl, and now we've run pop on Adam, and we've popped out that value, and so now we have Bob and Derek remaining. Okay, here I'm creating, I've got a dictionary, people A, okay, A, B, C, Adam, Bob, Carl, and then people B is another dictionary with Dave, Earl, and Fred, okay, and I'm going to take people A, and here if you want to kind of add more keys, like if you want to combine two dictionaries together, okay, you use update. You're updating the dictionary with these new entries, okay? And so you do people A plus update people B, okay? And then so people A will now have Adam, Bob, Carl, Dave, Earl, Fred, okay? So we've got all of these people in here, okay? You can't just take like a list. You can't just do a plus and add two lists together. So in the list, you could do list plus list, and you got a new list, okay? With a dictionary, you're not allowed to do that, okay? You have to specify update, okay? And the reason for this is because you have the possibility that you've got list A, or not list A, you've got dictionary A, and dictionary A has these keys, and then you've got another dictionary, and this dictionary has some keys in common with the first dictionary, right? So if I've got people A, it's a dictionary, and if I have another dictionary, people B, there might be keys that are in common, okay? And so which values do I keep? Do I keep the values in A, or do I keep the values in dictionary B, okay? And that's why you need to specify update A. So people A gets updated with people B, which basically means people B, that dictionary is newer than dictionary A, so anything that was in A is going to get overwritten by the stuff in people B, okay? So here, here's people A. We've got Adam, Bob, Carl, Dave, Earl, and Fred. And here, people C has Fred and Gary, okay? So if I say people A update with people C, okay, what's gonna happen is that this Fred value, 27, is gonna get updated with 99, okay? All right, and so we can see that's what happened. Fred gets updated with the values that were in dictionary C, okay? Whereas if you just did the plus, I guess it's not exactly 100% clear how the updates should happen. So so by specifying which update serves as which dictionary serves as kind of the base and which one serves as kind of the new entries or the updated entries, that's how you can do it. Okay, so you'll use a dictionary and you update with other things. Okay, and just like everything else, okay, you can always type in Python dictionary methods, and there's always going to be a lot more stuff that I don't have time to kind of cover. I'm always, whenever I come here, I'm never connected to the internet. A lot more stuff that I don't have time to kind of get into everything. You can always look up Python dictionary examples or method examples, Python dictionary methods. You can always kind of type that in and see what kind of stuff happens, right? So a lot of these kind of the so they're so stuff we've seen, clear and copy and get and then pop and update, okay, and then there's a lot more. So these are dictionary specific methods, and these are just functions that can be applied to a dictionary as well. Okay, so you can always go on online to look up more methods. Okay, dictionaries are cool in that we also have what we call view objects of a dictionary, a view object. And this is, it feels a little strange, okay? All right, but you can update a dictionary and the view object is dynamically linked to the dictionary, okay? So here I'm going to start off with my dictionary, Adam, Bob, and Carl. And if I say, what is this dictionary? What's the contents of the dictionary? We see Adam, Bob, Carl along with their ages or their numbers, right? 25, 19, 30, okay? I'm creating two view objects, okay? So you can have keys, values, and items. So keys is the view object of the keys. Values is the view object of the values, and items is going to be kind of the key value pairs. Basically a view object of the dictionary itself, okay? All right, so I'm going to say people.keys will be the names, people.values will be the ages, okay? So if I look at this, if I look at names, it looks kind of like a list, okay? But it's technically a dictionary view object, okay? And it contains the values Adam, Bob, and Carl. Ages, again, looks like a list, okay? But it's surrounded by this thing that says these are dictionary values. And that lets you know that they are still dynamically linked to the dictionary. Okay, so here is I am going to create a new entry in the dictionary. Okay, we're going to say Ed is 40. Okay, and I haven't even redefined this. I'm just saying what is names, okay, without needing to redefine it. Names now contains Ed in the view object, okay, and ages as well without redefining it. When I just call it, it has the value 40 in it as well.
Are dictionary view objects immutable, like tuples?
I don't think you can. I don't think dictionary view objects support assignment. I don't think you can. I'm trying to think. They're view objects, right? So it's like a window into the thing, and so I don't think you can. I'm pretty sure you can't do any kind of assignment with a view object. Immutable's a little weird because the view object does change as the dictionary updates, but you can't reassign stuff to it. Okay, so. View objects support only a couple things, okay? Like length or in, okay? So you can say, what's the length of ages? And it currently says there's 4 items in there. okay, is 35 in ages. In is a value there, and it says false, okay? You can convert ages to, say, a list, okay? And ages become a list, right? Except this is no longer dynamic. This is no longer dynamically linked to the dictionary. So you want to assign stuff, you can do that. So here I'm adding a new key value pair in the dictionary, and we can see that the view object gets updated. It now has the value 29 in there. Age list does not, okay? Here, let me just kind of, yes, I can't view dictionary.values does not support indexing. So these are just errors that I'm going to get. If I try to say ages Bob, this doesn't work. Okay, so this will create an items. So this is the other view object. Okay, and let's see. I don't think I can do. Can I do this? No. Yeah, yeah, we can't do any kind of assignment with this. If I try to assign something here, it's going to just change the value itself. But now we've got a view object with kind of tuples of the entries in the dictionary, the items. All right, is that okay? So that's dictionaries. Let me just check. Python dictionary view objects, and methods. Order. Okay. Doesn't have the stuff I want. Okay. Flow control. I think I can go really quickly through this stuff because I think we're all familiar with these concepts, right? So you've got if, else, else if, and else, okay? I guess the only thing that you gotta get used to is else if is one word, okay? It's elif, all right? And then, again, no curly braces. It's all based on the indentations, right? So after each of these statements, you put a colon, you indent, okay? When you dedent, then that tells you it's ready for kind of the next top level condition. And so here I've got x is -3, and then I say if x is 0, print x is 0. Else if it's greater, say it's positive, otherwise say it's negative. And you say that -3 must be negative. And then just like, I think we know this, right? If the if statement is true, the else if and the else will never get executed, right? So here I've got if x is greater than 0, we're going to say it's positive. And even though it's greater than 3, this will not get executed. Okay, so I think we're familiar with that. Okay. For loops. Okay, I think we're also good with for loops. Anytime you have something, so here I've got a list. This is what Python calls an iterable, okay? So so here a list, a tuple, range, strings, those are all iterables, okay? And so here I've got a list of values, 5721, and we're gonna say y is 0, okay? And we're gonna say for x in values, so it's gonna just take each value in that list, okay? And we're gonna print the x, and then we're going to do a plus equals x, right? So this is something that I wish R had, but we don't have. And so y plus equals is the same as a shorthand for y is equal to y plus x. Okay, and then so we'll get the running sum. Okay, so we get 5 running sum is 5, 7 running sum is 12, 2 running sum is 14, 1 running sum is 15. Those are your for loops. Okay. Strings are iterables. So we can say for a letter in UCLA, we're going to print letter.upper plus an exclamation point. So what is this going to do? So it's kind of like cheering, but it also exclamation points the space, okay? Because it's going through each character in the string, okay? But suddenly this gets very exciting, right? Okay, people, we have a dictionary, okay? And you can take the view object, all right? And if you put it into a for loop, okay, then it's going to make this become an iterable, okay? So it's going, now we have an iterable, kind of basically a list of tuples. And when you have a list of tuples, you can do stuff with this, right? So it says, so here it's going to, I've got 1, 2, 3, 4, 5 entries in my basically list of tuples, and each tuple is length 2, and that tuple will get unpacked into key and value, okay? So the first time we run it, this tuple has Adam and 25, and we unpack the two values so that Adam becomes key and 25 becomes value. Is that all right? So this is kind of a neat thing, this idea of unpacking. Now if I, so we've got, sorry, if we run this, we're going to get the key is Adam, the value is 25, key is Bob, value is 19, so on and so forth, okay? If I don't do this, right, so if I don't have to unpack it, okay? I can just say for entry in this, and we can say the entry is entry or something, okay? And what will this print out? Okay, so keep in mind this is what our thing is. This is going to, will I run into an error? Entry is currently a tuple. Let's see. I might run into an error. I might have to convert entry into a string. Yeah, okay, I get a type error because I'm trying to add a tuple to a string. Okay, so it does not like that. So I have to convert the entry into a string, okay? And so what we're gonna do is we're gonna basically, so when I iterate through people.items, which is this thing, okay? Each item is still the tuple, and so entry here is the tuple. And so here I'm gonna convert each entry into a tuple, and then I can print out the string plus a tuple, okay? And let me just do one more of these, okay? If you try to unpack something, okay, so here I've got tuples. The tuples are of length 2, and if I try to unpack a tuple of length 2 into something of length 3, it complains, okay? It's gonna error out, right? It says not enough values to unpack. I expected 3 because it says key, value, and thing, but the tuple only has 2 values in it, okay? So you get a value error in that when you're trying to unpack each tuple in here, each tuple has 2 items in it. It says, or 2 values in it. It can't do that. So anyway, these are your for loops for iterable objects, okay? A very important iterable object is what we call a range, okay? And range is basically the equivalent of when you create a sequence in R. In R, you do like for I in 1:1000 or something, and if you, that'll do 1,000 iterations. And basically, we don't write 1:1000, okay? We just write range 1,000, okay? And that's pretty much the equivalent in Python. So that's a range object. So if you want a sequence of numbers, just use range. So range 10 is similar to calling 0:9, okay? It's a range of length 10, but because Python likes to start at 0, it goes from 0 to 9, okay? So it creates a range of index 10 that starts with 0. You also, so often you'll just see range 10, but if you want, you can do, you can specify a start, an end, and a step size, okay? So range 10 will just say, we'll just create a range 0:10 object, all right? And here I can say for I in range 10, print I, and that will print out the values. Here the end argument tells Python use a space rather than a new line character. Print, by default, always inserts a new line character after it prints whatever object you asked it to print. But here we're going to say put in a space. Okay, range 510. What this does is it starts at 5, goes up to, but does not include 10. So this is going to go 5 through 9, okay? Which it's not obvious, okay? So you can take a range object and throw it into a list, and then it will create a list, okay? So we've got 5, 6, 7, 8, 9. Here we've got range 022, okay? And now I'm going to throw that into a list just so you can see the values. Otherwise, it's just going to say range 022, okay? And so if you do that, it starts at 0, goes up to, but does not include the end, okay? Up to, so in step sizes of 2, so it goes 0, 2, 4, 6, 8. It goes up to 18, but it does not include the end, okay? If I say 021 to, then it goes up to 20, okay? Because that last thing of 21, so it goes up to, but it doesn't include the last thing, okay? And if you try to say something like 20.1, it says I don't like floats, only integers, okay? But you will often, if you're reading code, okay, if you read Python code, you're often going to see these range objects, okay? They're very, very, very common, very prevalent, and you'll often see something like range 10,000, okay? And it's basically the equivalent for I in 1 through 10,000 or something like that, okay? But it starts at 0 and ends at 9999. Okay, while loops, I think we all know a while loop. So it runs until it becomes false, right? So I is 0, while I is less than 10, okay, print I, and don't start a new line, just put in a space, and then increment I by 1. Okay. What is the last value that gets printed, and what is I going to take when we finish our loop? Okay, last value that gets printed. Okay, value of I when we exit the loop. Indeed, okay. What's that? Yeah, it starts at 0, right? Because I is 0, and then, so this is true, and then it prints, and then 9, and it prints 9, and then it becomes 9 becomes 10, and then the while becomes false, so it quits. Okay, but I is now 10 at that point. Okay, we've got break and continue, and this is break, the equivalent of break and next. Okay, all right, so here we've got for n in range 20, right? So range 20 goes from what? N is going to start at 0 and end at 19, okay? And then we say if n is, we've got %2, so that's mod 2, right? So if n divided by 2 and the remainder, right? So if the remainder of n divided by 2 is equal to 0, continue, right? So what are we going to get? Are we going to get even numbers or odd numbers? So here it says if n is divisible by 2, continue, okay? And that ends this if statement. As soon as it hits the continue, it doesn't run anything else in the loop, and it goes to the next iteration, okay? So we start off with 0. 0 divided by 0 mod 2 is 0, okay? So we're going to continue, right? Then we go to 1. 1 mod 2 is not 0. So this does not get executed, but this does. Yeah.
Is that because print is an index? That's what
Yeah, print is not part of the if statement. It's part of the for loop, but it's not part of the if statement. Okay, because of the indentation. Okay, so we're going to get all the odd numbers, 1 through 19. This is not the most efficient way to do the Fibonacci sequence, but here, what does this do? Here I've got a tuple, 0, 1, and I unpack it to the tuples A, B. So A is 0, B is 1, okay? And I'm going to say A max 100, and we're going to start off with an empty list. All right, and I say while true, okay? So while true runs forever, right? While true runs forever until we encounter a break object. All right, and so while true, what do? I say create a tuple, A, B, and what values go into that tuple, okay? B becomes the new A, and then A plus B becomes the new B. Okay, so we're going to do, so we start off with A and B are 0 and 1, and then the next tuple will become 1 and 1, okay? All right, so A is now 1, so we're going to append 1 to this. And then at the next iteration, our tuple is currently 1, 1, and then B becomes 1, and then 1 plus 1 becomes 2, and we're going to append another 1 here. And then I got 1, 2, and then so A becomes 2, and B becomes 3, and we're going to append 2 here. Okay. All right, and we keep going, and so why is this not working? All right, so I don't know all the Fibonacci numbers. All right, keeps going to, all right, okay. So what will be the last number that we print out? Is it going to be 55, 89, or 144? Okay, so those are the Fibonacci numbers. Okay, so it goes 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89, 144. Those are your answer choices. Okay, so just in your, I guess, start off here at 34, 55. Okay, so A is 34, B is 55. And then what happens? Okay, A is, so we append 34. Okay, now we've got A is now 55. Okay. Are you guys even trying this, or are you just waiting for me to tell you the answer? The 89, okay? So we start off at 1, 1, 1, okay? We get to, the last thing we append is 89, okay? And so we have 89, and then B technically has 144 in it, okay? Like if I, oh, I'm sorry, because we quit, okay? So at this point, B has 144, and then we update this, okay, to the next number, okay? And so now A is over 100, so we break, but A actually, when we quit, A has 144 in it and B has 233 in it. So these calculations have been done, but because A has 144, we've quit before we appended anything. Okay. All right. Is that all right? Okay. We've got functions. We've already seen all of these things. Okay, if you call a function name without any parentheses, it just says this. You are talking about the function print. Okay, and then when you use parentheses, it calls the function, right? So now we've said print fall. Okay, and then you can say print 1, 2, 3. There's other arguments that you can provide for print, such as what separator character you're going to use. And we have this. You can always ask for help on print, even in a notebook. Help on print will do this, and so will the. And if you do question mark on the print, it brings up like the little interactive viewer. This little, at least on my browser, that's what it does. I don't know, maybe it's different for other people, but it brings up this little thing there. Okay, we can write our own functions. All right, so so the way you create a function, is by using the keyword define or def. Okay, so you say def, and then you say the name of the function. Okay, so here I'm defining a new function called shouting. Okay. And then inside that function, you provide the arguments, okay? So here I'm going to just say phrase, all right? And this is, I'm not doing any kind of type checking, okay? So if I put in numbers, it's going to complain and stuff, right? Okay, so here I'm going to just say take the phrase, put it into uppercase, and add 3 exclamation points, right? So here I'm defining this, okay? And right now I've got the innocent text that says, hi, my name is Miles. Okay, and then when we run it through the function shouting, suddenly it sounds very enthusiastic. And so we have that, right? Okay, if I try to put in an integer, I get an attribute error, because here I'm taking number 5, and the number 5 doesn't have this method, or technically it's an attribute called upper, okay? And so to kind of make it a little bit more acceptive of different types, I'm going to say here's the shout. The shout is going to, we're going to take whatever thing comes in as the argument and throw it into the string function to try to just force it into a string. Okay, then we'll make it uppercase, and then we'll add exclamation points to it. Okay, and then we'll return whatever that thing is. Okay. So we're redefining our shouting function. I put in 5, and now we're shouting the number 5, okay? And here I've got a dictionary. I throw that in, okay? And what it did was it took the dictionary, turned it into a string, okay? And then it made that string uppercase, which affects the letters in that string, but not the punctuations, and you just get this weird thing now, okay? But technically, that's what we have, okay? Here's something different from R, okay? You can have your function can return multiple values, okay? And it will return them as one object, which is technically a tuple, okay? It's going to return a tuple, so multiple values as a tuple, but you can unpack values into basically a tuple of names, right? So here I've got powers of a number, and if we look, it's going to return number, the square, and the cube, okay? And so inside this function, we've got number star star 2 to make the square, number star star 3 to make the cube, okay? So I'm going to do powers of 3, all right? And it returns a tuple, 3, 9, 27, all right? And then I can take this, powers of 3, this is the tuple 3, 9, 27, and it will unpack 3, 9, 27 into this tuple XYZ, all right? So X is 3, y, and z are 9 and 27. Okay. If I didn't provide three names, okay, if I didn't provide x, y, z, then it will just store the entire tuple into an object j. So j is the tuple for 1664. Okay, and you can subset j accordingly. Okay, and we already saw this, where if you have a mismatch of the number of names to unpack into, you get an error, right? It says too many values to unpack, right? So so here it expected 2 because we have two names, G and H, and when we're trying to unpack it, powers of 5, it has 3 values to unpack, 5, 25, 125. So it gives back an error, okay? And we encountered basically the same thing, but just the opposite way back here somewhere. Where here it said not enough values to unpack, okay? Where here it was expecting 3 values to unpack, but the tuple only had 2 values in there. Okay, but that's a handy thing. And so a lot of times, as you're reading other people's code, okay, you're going to see stuff like this. You're going to see x, y, z is equal to the result of some function, where the function returns like 3 things. So you might see things like later on when we talk about like dimensions, okay, of an array, it'll be like array.shape, and it's going to be like xy is equal to array.shape or something like that, okay? And it's basically unpacking the x and y array attributes. Okay. All right. Default arguments. This is just like R. Okay. So so here I'm just printing ABC, and it does that. Okay. If here the function stuff is expecting 3 arguments, and so if you don't provide 3 arguments, it says it's missing the argument. Okay. And so you can provide default arguments, and that way, if you don't provide the arguments, it'll still work. Okay. So we've got junk is this. Here, if you specify only 1, it's going to go into the first thing, 4. Okay. Here is I can specify just one of the arguments, say B. So remember, it's printing out ABC. So by default, no name assignment will go to the first. Okay. You can give it the thing here and say 1, 4, and 3. Here, 5, 10, 0 will go ABC, okay? If you do this, however, Python will get confused, okay? Because it kind of goes left to right, right? So it kind of goes here and it says the 5, and it's going to want to like assign this to the first position, okay? But then it sees A is 10, and then it gets confused, okay? So this is something that's different from R, okay? R, like, it will like match everything up, and everything that wasn't assigned, it's gonna try to like, by process of elimination, assign it somewhere, okay? But here, because it's kind of going, reading left to right when it's interpreting, it first assigns the 5 to A, and then it sees A is 10, and then it says, I got multiple values for A, I don't know what to do, and it quits out, okay? But if you kind of specify all of these things, then it's fine, okay? So you can say A is 10, B is 0, and C is 5, okay? Okay, I kind of threw this in here, okay? You can also have arguments of variable length, right? So you might want to be able to include like a list somewhere in there, okay? And you can do this by using what's called star args, okay? So I've got the variable function. This is just some called var function, all right? And it's going to print args. When you do this, whatever you provide args here, it's going to basically make a tuple out of it, okay? So here, into this just accepts one argument, but it's a variable length. So here I'm providing 3, basically a tuple of length 3 here, okay? And so when I run this, it sees args as a tuple, okay? And it does that, okay? And so this allows you to say, here I'm going to create something called print stuff, And what it's going to do is it's going to go through each value in this tuple, okay? And it's going to print out x after it's converted to a string, and it says has type, and it's going to print out the type of x, okay? After it converts that to a string. So here I've got print stuff 1, 2, high, and it goes through each of these things here. Okay, this is again, because it's a variable length function, you can give it an arbitrary number of arguments here, okay, and it doesn't complain, right? It's going to just run the thing for basically each item inside this thing, okay? So args, it sees args as a tuple, and it says, okay, you've given me a tuple, and you basically say for each item, x in args, do this thing, okay? Which can be useful if you want to have the ability to kind of throw in a bunch of extra stuff at the end, or just pass arguments onto some other function, okay? You can mix regular arguments and all of this other stuff. And I know
can you send it named arguments?
You can send it named arguments, okay? And that's technically called the quargs, the keyword arguments, okay? They just call this quargs, and you provided a dictionary. So you can provide named arguments, and this is useful for like some kind of graphic thing, and you want to specify the axes or the titles each time.
Can you send both?
Yes. Yeah.
In one, because this is very similar to the 3 dots in R.
It is very similar to the 3 dots.
The 3 dots in R will take named and